oops, we're going to start talking about analyzing these graphs and figuring out how to explain the domain and range and these two behaviors here at the bottom of the page. Those are going to be our new things that we're adding in. So before I can start looking at asymptotes, I have to factor this. So I'm going to make myself my t-chart. I'm going to multiply to make -7 and add to make -6. Another thing that I always look at, this numerator here is x minus 7. So I want to try to get -7 as one of the numbers in here. So -7 times +1 would give me -7, and -7 plus 1 does give me -6. So those two numbers are going to be my factors in the bottom. So I'm going to have x minus 7 and x plus 1 as my factored denominator. And then the numerator is going to be x minus 7. The factor that cancels out, which is x minus 7, that's going to be the one that helps us to figure out the hole in our graph. So I'm going to set it equal to 0 and solve for x. It does end up being the opposite of the number we see. So this is going to be x equals +7. And then in order to find our y value that's going to match up with our x value, I'm going to take our simplified function. So this is our simplified function that I'm using, and I'm going to substitute in where I see x, I'm going to substitute in 7. So my y value would be 1 over 7 plus 1, which is going to simplify to 1 over 8. Now, I know that 1/8 is very difficult to draw on a graph like this. We're going to do our best. Remember, this is a rough sketch. So I'm going to go over 1, 2, 3, 4, 5, 6, 7, and up a little tiny bit, and that's going to be where that open circle is for the whole of our graph. The vertical asymptote is going to come from what is left over that didn't cancel out. So this is coming from x plus 1 being equal to 0. So that's going to tell me that my vertical asymptote is at x equals -1. Now I am going to start color coding a little bit just to help us see what pieces are connecting in terms of these things that we're finding. So -1 is here. So this is x equals -1. So now what I can do is get the domain from the vertical asymptote, the whole of our graph, and those are going to be the two x values that are not allowed to happen in our domain. So I would write that x cannot equal -1 and x cannot equal 7. Those, when we were solving, those were our two extraneous solutions that came from the denominator, our two no-no answers as we were calling them. So those are going to be the things that we put in as our domain. Now in an instance like this, where we have two polynomial functions in our rational function, and it's not the general form that we started with graphing, in order to find our horizontal asymptote, I am going to look at, I'm going to grab another color, I'm going to look at my two leading terms in the numerator and the denominator. So in this case, the denominator has a bigger exponent. So if the denominator's exponent is bigger, our horizontal asymptote is at y equals 0. So that's going to be our x-axis. And our horizontal asymptote is going to be the thing that buddies up to help us find the range. So in this case, the only value that's not allowed to happen for y is 0. So we're going to go ahead and do a rough sketch of our graph. And I'm going to do this in purple just so you can see it a little bit better on my graph paper. So the top portion of my graph is going to be in this top right section. I'm kind of using my asymptotes to, I'm kind of thinking of them as a quadrant, so I'm using my brain, or it's the asymptotes are helping my brain to kind of determine what sections of these graphs it's going to be in. Now, when we talk about end behavior is going to go off of what is happening with these arrows that are coming in from the, like, all the way on the right and all the way on the left. So this part, in terms of writing the end behavior, it is always going to be the same in how we write that I'm looking at the left arrow and how I'm looking at the right arrow. This part is always going to be the same. This is our right arrow, or our right side. I didn't leave myself enough room in that parentheses. And this is going to be our left side. So as x goes to the right, and my numbers get bigger in the positive direction, this arrow is coming really, really close to our y asymptote, or our horizontal asymptote. So these values are going to get close to 0. So you'll notice that end behavior buddies up with our horizontal asymptote value. So these things are going to coincide. Those two things are going to help us with that information. And on the left-hand side, I'm also approaching the asymptote of 0. So then again, I'm going to see y approaching 0. So end behavior is our left and right arrow, and it's related to our horizontal asymptote when we're dealing with a rational function. When we're talking about asymptotic behavior, or what is happening at our vertical asymptote, I am going to look at what is happening on both sides of x equals -1. And we are going to write this in a very specific way. And the way that we write it is always going to be the same, regardless of what our asymptote number is. This extra little piece is always going to be how we write it. So we are going to look at this being the right side of our asymptote. This is going to be the left side of our asymptote. And we are going to denote that with a plus sign or a minus sign. So we are always writing it as x approaching my vertical asymptote from the right, and x approaching my vertical asymptote from the left. So this number in here, that's the actual number of our vertical asymptote. So the only piece that really changes is that actual number. The rest of this format is going to stay the same. So I'm going to write my end behavior for our asymptote as x approaching -1 from the right-hand side and x approaching -1 from the left. And then what we're going to do is talk about what's happening with the y values. Now, since we're looking at our vertical asymptote, it's either going to be going up or it's going to be going down. In this case, the right-hand side is going up and the left-hand side is going down. So going up is positive infinity for y, and going down is negative infinity for y. So the pieces that are going to stay the same in terms of behavior, these two pieces are going to look the same. It's always going to be x approaching infinity and x approaching negative infinity. And your job is to match that up with the horizontal asymptote. And then these pieces are going to stay the same, but the number inside of here is going to change based on the vertical asymptote. So again, color coding this, the asymptotic behavior is buddied up with the vertical asymptote. So you're either looking at the vertical asymptote or the horizontal asymptote to figure out your behavior, whether it be end behavior or asymptotic behavior. So we're going to look at another one. And again, I am going to have to factor in this case. So I'm trying to multiply to get negative 12 and add to get negative 1. I'm going to try to use negative 4 as one of those factors and see if it will work. Negative 4 times 3 does give us negative 12. And negative 4 plus 3 does also give us negative 1. So those are going to be our factors. So we're going to have x minus 4 in the numerator and x minus 4 times x plus 3 in the denominator. So the one that cancels out is the whole. So x minus 4 being equal to 0 is going to give us the whole. And the one that's left over being equal to 0 is going to give us that vertical asymptote. So my simplified function, should be 1 over x plus 3. So this is our simplified function that we're going to use for finding the y value that matches with our x value for the whole. So we're going to use x equals 4. And I'm going to substitute to find y 1 over 4 plus 3, which is going to simplify to 1 over 7. Again, I realize 1 over 7 is a very difficult number to graph accurately, so we are going to 1, 2, 3, 4, just go up a tiny bit and make an open circle there. Again, we're doing a rough sketch. We're doing our best. So this is going to be for our vertical asymptote, x equals negative 3. So I'm going to go in. What color did I use? I used blue for the vertical asymptote. So 1, 2, 3. There's my vertical asymptote. And then horizontal, I'm going to look at what's happening with these leading terms. So the bottom is bigger. So again, in this case, we are also going to have a horizontal asymptote that is still y equals 0, because if the denominator exponent is bigger, our asymptote horizontally is y equals 0. So domain is going to match up with the vertical and horizontal asymptote, or excuse me, the vertical asymptote and the whole. So here we have x cannot be negative 3 and x cannot be 4. Our range matches up with our horizontal asymptote. So here our range is y cannot be 0. So let's go ahead and graph this. And again, I'm just doing a rough sketch. I did check Desmos to get my y-intercept, just so I had a general idea of where that should be. I need to grab my charger so I can plug in my computer quick. So when we're looking at our end behavior, we are still going to be looking at the left and right arrows. So end behavior matches up with horizontal asymptotes. So I'm looking at those two things matching up with that horizontal asymptote. It is always going to say x going to positive infinity and x going to negative infinity. It's just the right and the left arrows. So positive infinity would be the right-hand side. Negative infinity is going to be the left. And we are approaching our horizontal asymptote, our y value of 0. Our asymptotic behavior, or our behavior around our vertical asymptote, is going to be happening around x equals -3, and we're going to talk about it on the right and on the left. So the right side of that is going to be x approaching -3 from the positive side, or from the right-hand side, and the left is going to be x approaching -3 with a minus. And we're putting them in the same location as the exponent. That is just a notation. It's one of those things you have to just pop into your memory bank and keep track of. So in this case, this is going off of that vertical asymptote. So I'm going to look at my up arrow and my down arrow and then figure out if that's on the right or on the left. So up in this case is on the right. So y is going to infinity on the right-hand side of the asymptote, and y is going to negative infinity on the left-hand side of the asymptote. So the last one that I have for us to do together is a general form, so we don't have to factor. We're going to talk about how we have shifted our graph. And in this case, because there are no factors that are going to cancel out, there is no hole for this graph. Let me make sure I do my colors the same. Our horizontal asymptote is going to match up with our range and our end behavior. And that's going to be what vertical shift we have done. So this is moving our graph up and down. So here our horizontal asymptote is going to be y equals 4. And our vertical asymptote is going to come out of what's happening in the denominator. So our vertical asymptote is going to help us with our domain and our asymptotic behavior. It is the opposite of the number we see. So this is going to be x equals +2. So our domain cannot be our asymptote, so x cannot be 2. Our range cannot be our horizontal asymptote, so y cannot be 4. So I'm going to go ahead and graph those two. Now we do not have a hole, so I don't have to worry about that. So this is x equals 2 for a vertical asymptote. 1, 2, 3, 4. Here is my horizontal asymptote of y equals 4. Now the only thing we haven't talked about so far out of this is this -1 in the numerator. Since the numerator has a -1, it's going to be reflected or flipped upside down. So instead of living in this part of my graph, it's actually going to be flipped down here. So we're going to, and again, I did check my x and y intercepts ahead of time in Desmos, and these do happen to be crossing very close to our asymptotes. So this is what our graph would look like in this case. Now, end behavior-wise, in terms of what's happening around our horizontal asymptote, we're still going to be doing the same thing. We're still looking at our left and y arrows, and they're still approaching this horizontal asymptote. So from the right y is going to our horizontal asymptote. And from the left, y is going to our horizontal asymptote. So again, this is the right arrow and this is the left arrow. What's going to be different in this case is our asymptotic behavior, because we have done a reflection. So for the right side, x is going to be approaching 2 with a plus to represent the right. But on the right-hand side, this time our arrow is going down. So here it's going to be going to negative infinity on the right. And as our graph approaches our vertical asymptote from the left, we are going up. So this is going to be y approaching positive infinity. So that is how a reflection changes our asymptotic behavior.